This video was produced by the UCD Math Support Centre in conjunction with the UCD Access Centre. Two events are mutually exclusive if they have no outcomes in common. Another way of saying this is the probability of event E and event F occurring is equal to 0. This means that it's impossible for both event E and event F to occur together. For example, if we are drawing one card from a deck of cards, it is impossible to draw in the same draw a king and a jack, as we are only drawing one card. The definition for mutually exclusive events has been asked on the Project Maths paper in the Leaving Certificate before. We can represent mutually exclusive events on the Venn diagram. As you can see, event E and event F have no intersection. Event E and event F have no intersection because they have no outcome in common with each other. In comparison, for not mutually exclusive events, event E and event F have an intersection on the Venn diagram. For example, event E could be drawing a heart from a deck of cards, and event F could be drawing a king from a deck of cards. If we drew the king of hearts, it would lie in the intersection, as it fulfills both event E and event F criterion. The addition rule in probability is the probability of E or F occurring. When events are mutually exclusive, this is equal to the probability E occurs and the probability F occurs. You may have seen it written as the probability of E union F. This is the same rule. Let's go back to our example using cards. Let E be the event of drawing a king from a deck of cards, and let F be the event of drawing a queen from a deck of cards. The probability of drawing a king or drawing a queen is equal to the probability of a king and the probability of a queen. The probability of drawing a king from a deck of cards is 4 over 52, and the probability of drawing a queen from a deck of cards is also 4 over 52, and this is because there is 4 queens in a deck of 52 cards. Adding these together, we'll get 8 over 52. Simplifying, this is equal to 2 over 13. The addition rule, or the OR rule, is different for not mutually exclusive events. The OR rule, or addition rule, for not mutually exclusive events is given by the probability of E or F is equal to the probability of E and the probability of F less the probability of E intersection F. The reason for this is if we go to our not mutually exclusive Venn diagram and we consider the probability of E, we're taking into account all of this area. And then if we add on the probability of F, we're taking into account all of this circle. That means we have included intersection twice. We need to remove then the second extra intersection. Let's try this with our example. The probability of the event E, a heart, or the event F, a king, is equal to the probability of a heart and the probability of a king less the probability of intersection between a king and a heart. The intersection between drawing a king and drawing a heart is drawing the king of hearts. So this is equal to the probability of drawing a heart. There are 13 hearts in the deck and 52 cards. That's 13 over 52. Probability of drawing king is 4 over 52. And there is only one king of hearts in the entire deck, so that's minus 1 over 52. Adding this up, 13 over 52 plus 4 over 52 is 17 over 52 minus 1 over 52 will give us 16 over 52, and simplifying that will go down to 4/13. That concludes this session on mutually exclusive events and the addition rule, otherwise known as the OR rule.